Now, a little bit more tricky than parallel lines are perpendicular lines. And how do we understand the slope of perpendicular lines? Well, for a proof that's a little bit more difficult or complicated than I have space to do, what we know is that the slopes, the product of two lines, or the slope of two lines, if they're perpendicular, the product is -1. And so knowing that fact can help us out. So let's look at that and play in this example. Can we come up with the name of the line that passes to the point 3, -5, but it's perpendicular to this other line? Well, this other line's not written in slope-intercept form, so understanding what a slope is not quite readily apparent. So let's work that into slope-intercept form. Made sure I subtracted x from both sides and added 8 to both sides. Divide both sides by 4. And the slope in this one is -1/4. So I have the slope of the perpendicular line. To find the slope of the other line that we want, I remember that the product of their slopes, so -1/4 times something equals -1. And what is that going to be? It's going to be its inverse, or its reciprocal, I guess is a better way of saying that. And it's going to also be the opposite sign. So -1/4 times 4 produces a -1. So now I have the slope of the line I want. Slope is going to equal 4, and I have a given line. So we can use point slope. So y minus a -5 equals slope, which was 4 times x minus a 3. Solve that for y. Subtract 7 from, or 5 from both sides. And there you have it, y equals 4x minus 17. And that's the line that's perpendicular to the given line.